This is Algebra 1, Practice Quiz 7.2. In number 1, I see some parentheses and I have this 3 that's to the power. I can distribute this 3 to both of these two bases here. So let me zoom in so I can see this a little bit better. This 3 is going to be distributed to this n and this other 3. So our new problem is going to be 3 to the power of 3, n to the power of, okay, I had a power to a power to a power is multiply. So it's going to be 2 times 3 to get 6. And this is technically correct, but I want to go ahead and practice expanding 3 to the power of 3. If you have forgotten, 3 to the power of 3 is the same thing as 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So this is going to be 27n to the power of 6. Final answer, and box it. Let's check the work. 27n to the power of 6 for number 1, 27n to the power of 6 for number 1. And number 2, kind of the same thing, you're going to be distributing this 2 into all of the different bases. I have 1, 2, 3 different bases, so our new problem is going to be 4 to the power of 2, and again, because we're doing a power to a power, we're going to be multiplying. 3 times 2 is going to be 6, so this is going to be m to the power of 6. n to the power of 2 times 2, which is going to be 4. Interestingly, if you had added those, you would have gotten the same answer doing an incorrect operation. From here, I can simplify. 4 to the power of 2 is 16. 16, m to the power of 6, n to the power of 4, and that's as far as I can go. Let's check our work. 16, m to the 6, n to the 4. 16, m to the 6, n to the 4. And number 3, we have lots of parentheses. And the first thing that I want to do with these parentheses, I want to simplify all of the stuff on the inside before distributing the 2 to see if that helps. I do want to point out yet again, as I always do in every video, every lesson, the path that I choose is not the only one all-knowing answer. You can choose so many different paths to get the same result. Some of your paths might be more efficient than mine. Maybe my path is more efficient than yours. I'm hoping that you're not being forced into doing it the way that I'm doing it. I'm seeing that this negative 3 is going to be distributed into, I'm going to do this in pen, this negative 3 is being distributed to both this n and this 2, so our new problem is going to be n to the power of 3 times 2 to the power of negative 3, n to the power of, and remember, power to a power means multiply. 4 times negative 3 is negative 12. And all of this is to the power of 2. From here, I'm going to multiply n and n. Oh, they're the same base, which means I'm going to add their exponents 3 and negative 12. So from that, I have still this 2 to the negative 3, and now I have n to the power of, okay, adding 3 plus negative 12 is negative 9. And this is all still to the power of 2. Let's go ahead and just distribute that 2 now. You could have done it at a later point, but right now is a good time. So I can say this is now going to be 2 to the power of negative 6, n to the power of negative 18. Again, I had a power to a power, so I multiplied, power to a power, so I multiplied. I'm basically done. I just need to get rid of these pesky negative powers because the instructions up here say that we can only contain positive exponents. So I need to flip this. Remember, technically all of this is over 1. So this is going to be flipped to the denominator. This is going to be flipped to the denominator. And I'm going to get the following. I'm going to get 1 over 2, not to the negative 6, but positive 6. And n, not to the negative 18, but positive 18. And there's our final answer. Remember that typically speaking, we don't write a 1 unless it is needed to make a fraction. For example, you don't write 1x to the power of 1 over 1. While technically this is the same thing as x is the most simplified version of that. The only time that you don't write these 1s is when it's in the top by itself. Oh, do we check our answer? 1 over 2 to the power of 6 and the power of 18. Wait a second. Usually 2 to the power of 6, we expand a little bit. I'm going to go ahead and say that's not quite our final answer. Let me erase my box here and move this up. I want to move you right there and just do my equal to sign and have my final equal to sign down here. How do I do 2 to the power of 6? Well, 2 to the power of 6 is 6 of these. 1, 2, 3, 4, 5, 6. 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. I don't want to do 16 times 4. I want to do 16 times 2. That's much easier. 16 times 2 is 32, and 32 times 2 is 64. So my final answer is going to be 1 over 64 n to the power of 18. Final answer, and box it. So let's check. 1 over 64 n to the 18. 1 over 64 n to the 18. Excellent. On to number 4. All right, I see in the numerator I have a bunch of these x's. They're all being multiplied, so I'm going to be adding their powers. This power here is technically a 1, which I'm going to write in ink. And let's go ahead and do that now. We'll leave a space here for a coefficient. So I have x to the power of, I'm going to add 1 plus 2 plus 3, which is going to add up to 6. And I'm going to multiply all the coefficients. 2 times 3 is 6. 6 times 2 is 12. So I'm going to have a 12 in the numerator. The denominator, I'm going to leave the same, 4x to the negative 3. I see some numbers that can be reduced for our coefficients. I can divide both the top by 4 and the bottom by 4. And that's going to leave me with a 3 over 1. What about our x's? You can only have one x in your final answer, and I have 2 of them. So which one is more positive? That one. So that one is living in the top. Our answer is going to be also in the top. Because we put our answer on the top, it's going to be top minus bottom. And I'm going to write this out because I want to be careful. I want to do top minus bottom, and bottom was a negative, so you will have a double negative in this case. When negatives kiss, they become positive, and this is really x to the power of 9. So my final answer over here, I think I have enough room, is going to be 3x to the power of 9. Final answer, box it. We don't write divided by 1 to simplify our answers. 3x to the power of 9 for number 4. 3x to the power of 9 for number 4. Let's do that in ink so I know that I checked it. Halfway done. Now we get to the harder half, right? All right, and number 5, I'm going to distribute my negative 3 since nothing on the inside of the parentheses can be simplified by itself. When I distribute this negative 3, I distribute it to both of these 2 bases, and I'm going to leave the numerator alone. The denominator is now 2 to the negative 3, x to the, okay, be careful, power to a power means multiply. Negative times negative is a positive, 1 times 3 is 3. All right, anything that has a negative power underneath it, the entire unit moves up, or it moves to the other side. So it was in the bottom, now it's going to be in the top. And I'm going to actually show that in my work. This thing is going to come up to the top, and my problem is going to be 2 to the positive 3 all over x to the power of 3. Don't forget the original x up here. That x was technically to the power of 1, and notice I can only have one x in my final answer. Right now I have 2. So notice that the denominator has a larger exponent, so my x is going to live in that denominator. So here's my denominator, x to the power of, and then I'm going to do bottom minus top. 3 minus 1. Well, I'm just going to simplify it. 3 minus 1 is 2. We all know that. What about 2 to the power of 3? 2 to the power of 3, hopefully you have memorized, it's just 8. And there's my final answer. 8 over x squared for number 5. 8 over x squared for number 5. On to number 6. In number 6, oh, check it out, I got a power of 0. That means this x is gone. This x to the power of 0 is 1, which again is the equivalent of scribbling the whole thing out, and I only have this 2 left over. And I also am going to distribute this negative 4. There's only one base here, so it's not really distributing. It's just remembering power to a power means multiply. Negative times a negative is a positive. This is going to be x to the positive 12 times 2x in the numerator. The denominator is just going to be 2. Ooh, check this out. I see a 2 and a 2. If I see the same thing in the top and the bottom, you just cross-cancel. Cross, cross, you're gone. All right, and notice that we also have technically a power of 1 for this x, and we are multiplying. We have multiplication with the same bases, which means we add their powers. 12 plus 1 is 13. So this is going to be x to the power of 13, and that's as far as we can go. Final answer, box it, x to the power of 13. X to the power of 13. We're on it. 2 more problems left on our practice quiz. And they are gnarly. Look at that. I'm really hoping that we can simplify something in there, and we cannot. So I need to distribute that 2 into all of these 3 terms. Here, here, and here. Let's rewrite. I have a to the negative 2, rewrote u. B to the power of 3, rewrote u. Rewriting the denominator, it's 2a to the negative 2, b to the power of 4. The only thing that I'm going to change is the distribution. The distribution is going to be 2 to the power of 2, a to the power of 2, and b to the power of, we have a power to a power, which means we multiply, and you get negative 2 times 2 is a negative 4. All right, I'm noticing I have multiple a's and multiple b's in the numerator, so I'm going to combine those also. I just have one a and one b in the numerator. I can also simplify the fact that 2 squared is 4. Let's do that right now. 2 squared is 4. Boom. Denominator, I'm not going to touch. I'll go ahead and rewrite. 2a to the negative 2, b to the power of positive 4. All right, let's work on our a terms. All the things in the numerator are being multiplied. Multiplication of the same bases, a and a, means I'm going to add their exponents, 2 and negative 2 and 2. So I'm going to add negative 2 and 2 together, and I get 0. kind of nice. You can see where I'm going to be going with that. And then what about our b terms? So again, we're multiplying the same basis, so we're going to add their exponents. 3 plus -4 is -1. All right, so far so good. Anything to the power of 0, by the way, is 1, which again is the equivalent of ignoring that thing. It's just crossed off. So everything that has a negative power, let's go ahead and move you. So I have a 4 in the numerator. Well, the b to the -1 is going to be brought down here. This a to the -2, I'm going to be bringing it up here. A to the, not -2, but +2. In the denominator, I have a 2, and then I have b to the power 4, which was originally there, and this b that was a -1, but is now a +1. All right, I can also reduce 4 over 2 right now. I can divide the top by 2, divide the bottom by 2, and this is going to be 2 over 1. And finally, I can add these powers because I have multiplication with the same bases. 4 plus 1 is 5. This can be b to the power of 5, and don't forget our a to the power of 2 in the numerator. We don't really write a coefficient of 1, so I'm going to go ahead and erase that one right now, and that should be our final answer. 2a squared over b to the power of 5 for number 7. 2a squared over b to the power of 5. We got it right. Our last problem for a practice quiz 7.2. All right. I see a lot of powers of zeros. Look, there. All of those terms are going to be scribbled out. They go to 1. So this a to the power of 0 is 1. This b to the power of 0 is 1. This b to the power of 0 is 1. Again, that is the equivalent of scratching you out, scratching you out, scratching you out. You're gone. All right. So I'm going to simplify the numerator by distributing this -2. I'm going to do it in a different color. This -2 goes into just these two terms, and this is now going to be b to the -2, c to the -2. In the denominator, I'm noticing my coefficients. I have a 2 and a 2. 2 times 2 is 4. What about my a's? Let's count up all the a terms. Notice that everything down here is being multiplied, so I'm just going to add up, and notice this is also a power of 1. This is a power of 1, and now I have powers in all of these things. I'm going to add my a and a exponents. I have a +1 and a -1. That adds up to 0. There are no a terms, it looks like. What about our b terms? There aren't any b terms. All right. What about our c terms? Okay, for our c terms, I have c to the power of 1, c to the power of 3. I'm going to add those exponents together, and it's going to be c to the power of 4. C to the power of 4, and I think I get everything. Let me just double check. Got that 2, got that 2, got that a, got that c, got the a to the -1, got that c to the 3. I think I got everything. All right. So from here, again, that a to the power of 0 is going to go to 1, and it's the equivalent of scratching that out. And let's just go ahead and move all the things with negative powers. That had a negative power, bring it to the bottom. That had a negative power, bring it to the bottom. Nothing is left on the top, so I have a 1 left in the top. In the denominator, I have a lot of stuff. I have a 4, I have a b squared. I had an original c to the power of 4, and I brought down a c that was -2 and became a +2. The last thing that I need to do now, I have a c and a c. Those are the same variable. I can't have 2 c's. I can only have 1. So I'm needing to add those two exponents because of the multiplication that's happening with their bases. And I get my final answer of 1 over 4b squared c to the power of 6 for my final answer, which I will then box. Let's see. 1 over 4b squared c to the 6. 1 over 4b squared c to the power of 6. And that concludes practice quiz 7.2 for Algebra 1. Thank you for watching.